Example number 6, draw the shear and moment diagrams for the beam shown in the figure. As we can see here, we have a cantilever beam with a uniformly varying load or UVL. The first thing that we are going to do here is to compute for the reaction at the support. Since we have a fixed support here, so we have 3 reactions. One vertical, and this is the AY, and we have one horizontal, the EX, and we have, of course, the moment. If we are going to summate forces horizontal is equal to 0, taking the direction to the right as positive, we can see here that the AX is equal to 0. And if we are going to summate moment at point A, this is equal to 0, taking the clockwise direction as positive. So, kukompute muna natin yung resultant ng load natin. And this is just the area of the triangle. So we have here 1/2, the base is 9, and the height is the magnitude of the load, which is 10 kilonewton per meter. And we have here 45 kilonewton. This 45 kilonewton can be found at 1/3 from the 90-degree side, and we have 2/3 naman dito sa kabila. So meaning in here we have 1/3 of 9, so that is equal to 3, and the 2/3 of 9, and this is equal to 6. And this is the location of the resultants of our load. Okay, so first we have here the moment at A, and we assume that it is directed counterclockwise, so this is negative. Then this 45 kilonewton here will rotate clockwise, so it is positive. Multiply by the moment arm. The moment arm from the point A is 6, and this is equal to 0. So computing for the value of the moment at A, this is equal to 45 times 6, and we have here 270 kilonewton meter. So we have here 270 kilonewton meter. So since we have a positive answer, meaning the assumption that the moment at A is directed counterclockwise is correct. So meaning this is directed counterclockwise. In order for us to compute for the vertical reaction at A, so we have to summate forces vertical is equal to 0, taking the upward direction is positive. So we have here AY, assume directed upward, so it is positive, minus we have the 45 kilonewton, it is negative because it's directed downward, and this is equal to 0. So solving for the value of AY, then AY is equal to 45 kilonewton since it is positive. So the assumption that AY is directed upward is correct. So next thing that we are going to do is to cut the beam anywhere between this point A and B. So this section here will represent the segment AB. So for the segment AB, we have here the support, and of course we have the AY here equal to 45 kilonewton, and we have the moment at A, which is equal to 270 kilonewton meter. Now, if this is distance x, then of course this is y. So we have here the resultant of the load for the segment AB, which is equal to 1/2 xy. This section here is for the limit 0 less than or equal to x less than or equal to 9. Okay, so let's compute for the value of the y. So we will express the y in terms of x, and if this is the case, Then we have here the y, and this is the x. The total length here is 9, and this height here is equal to 10. So solving for the value of y by ratio and proportion, we have y is to x and 10 is to 9. So y is equal to 10x over 9. Since the resultant of the load is r, so let's compute for the value of r. So r is equal to 1/2 xy, but y is equal to 10x over 9, so we substitute 10x over 9 here. So we have here 10 divided by 2, so that's 5x squared over 9. Okay, so in order for us to determine the equation for the shear, we just summate the forces vertical is equal to 0. Since we cut the beam here, then we exposed the shear and the moment. And of course, we have the normal reaction, which is just equal to 0. So, in the previous problems ay hindi ko na siya pinapakita. And kung magkaroon man siya ng value, ay hindi naman siya makaka-apekto sa ating shear and moment diagram. Okay, so we have the shear is equal to the vertical loads. So we have here 45 kN upward minus the resultant of the load, that's 5x squared over 9. And itetest natin yung shear natin at x is equal to 0 and x is equal to 9, since this is our lower and the upper limit. So what we're going to do is to input our equation here. So 45 minus 5 x squared over 9. So calc 0 and we have 45. So the shear at 0 is equal to 45 kN, and at x is equal to 9, so calc 9 and we have here 0. So the shear at 9 is equal to 0. Okay, so how about the equation for the moment? So for the moment, we have to summate moment at the section, and we have here moment is equal to 45 will create a clockwise rotation. So we have here 45 multiplied by the moment arm, that's x, minus, since this resultant here will create a counterclockwise rotation, and this distance here is just 1/3 of x. So the resultant, which is equal to 5x squared over 9 multiplied by the distance x over 3. So we have here the moment as the reaction at A, and this is counterclockwise, so we have here negative 270. Simplifying this, and we would have our equation is equal to 45x minus 5x cubed over 27 minus 270. And we now determine the value of the moment at x is equal to 0 and x is equal to 9. So input lang natin sa calculator natin, and we have here 45 minus 5x cubed over 27 minus 270. So at x is equal to 0, the moment at 0 is negative 270. So moment at 0 is equal to negative 270 kilonewton meter. And at x is equal to 9, so we have here the moment is equal to 0. So the moment is equal to 0. So the moment at 9 is equal to 0. And it's time for us to draw the shear and moment diagram. Okay, so at x is equal to 0, the shear at 0 is equal to 45 kilonewton. So at 0, we have here 45 kilonewton. And at x is equal to 9, the shear at 9 is equal to 0. So the shear at 9 is equal to 0. And we now decide for the curvature of our shear diagram, since we have here the degree 1 curve sa ating load diagram, so we are expecting a degree 2 curve dito sa ating shear diagram. Now, the question is it concave downward or it is concave upward? So, tingnan natin. If we are going to recall the idea of the dYIX, so we have here, for decreasing, bend the y-axis, and for increasing, bend the x-axis. Since this load here is increasing, so from 0 to 10, so it's increasing, so meaning we will be using the IX. So we are going to bend the x-axis. Now, this is our first point here, and this is our second point, meaning this point here is in quadrant 4. If it is in quadrant 4, then this is the location of the x-axis, and this is the y-axis. Since we are going to bend the x-axis, therefore, this is the correct curvature. And this is our shear diagram. And kung nalilito tayo doon sa idea ng dYIX, we can check actually the equation for the shear, no? And as you can see here, we have negative coefficient for the x square, so meaning it is a parabola facing downwards. It is a parabola facing downward here. Okay, so how about the moment? For the moment, we have at x is equal to 0, the moment at 0 is 270, and x is equal to 9, the moment at 9 is equal to 0. So in here we have negative 270, and this is equal to 0. Now, applying the idea of the dYIX, we have here our y-axis, and this is the x-axis. Now, the shear diagram will be the basis on drawing the curvature of our moment diagram. Since we have here decreasing from 45 to 0, ibig sabihin we will be using the dy, no? I-bend natin yung y-axis. So this is the y-axis, therefore this is the curvature, no? Kung sa case naman na ito ay increasing, so x-axis naman i-bend natin, so ito naman yung magiging curvature natin, no? Okay, so this is our moment diagram. Now, if we are going to compare the moment equation with the shear equation, so what we are going to do is to take the derivative of the moment, no? So kung kukunin natin ang derivative ito, then we would have here the derivative of the moment with respect to x is equal to the shear, which is equal to 45x, so the derivative of that is 45, minus 3 times 5, so that's 15 over 27, so divide natin by 3, that would give you 5 over 9, and we have here x cubed minus 1, that's x squared, and the derivative of 270 is 0. And this is actually the equation of our shear, no? So yun yung pang-check natin kung tama ba yung shear equation natin from the moment equation. Okay, so what are the possible questions na itatanong sa atin? We have the value of the maximum shear, and that is 45 kilonewton, and the value of the maximum moment, that is negative 270 kilonewton meter. No? So for the next video, I am going to solve this problem using the area method naman.